So whenever we talk about any error, let's take it as 10 plus minus 0.1. This why we put here plus minus, because that's an error, means that can be here in this case, that can be 9.9 and can be 10.1, right? This is the error here. So at the time of addition of any two errors, let's take this one error and one more, that's this error, and this error containing and this error containing. So addition of these two error, how would we add them? The value here may be 10 plus 0.1 and maybe 10 minus 0.1. Here the value can be 5 plus 0.2 and 5 minus 0.2. So there are four possibility to be combination of them, and the maximum output result would be given only when in both cases there would be plus and they would get added up. Okay, so the result we get from here is these two and these two, right? And when we add them, we would add this one to this one, or this one to this one, this one to this, and this one to this. So there are four possibilities. So we may write this as 10 plus 5, because every time we would get 15, so we can write as 10 plus 5. And the possibility of getting here the addition of error would be, when this get with this, it would be 0.3. when this get with this, it would be minus 0.1, right? If this get with this one, it would be 0.1, and when this get with this one, it would be minus 0.3. So what's the maximum value? When we write here plus minus, so what will be if we write 0.1, this will be the minimum value. So this plus minus says that the value may lie from this one to this in a specific way. I mean to say that the maximum permissible error can be 10 plus 5 plus minus 0.3. So in this case, what we did is added the error here, and the resultant error would be this 0.3. Okay, so at the time of subtraction, when these two get subtracted, what happened? The same thing is happen when these get subtracted, all get chance with each other, and the maximum would be when these two get plus and this middle one get minus. This gives maximum, and we need to find the maximum one so that we can find the maximum permissible error. So at that time also, the change in you may say it as the error, that's delta x would equal to delta, this value is x and this value is y, so this would equal to delta x plus delta y. This would be the error in the case of subtraction and in the case of addition also. In both cases, this will be the confirm. So now what's about the error during multiplication of two errors? That is, let's say there is 100 plus minus 2 and the other is 50 plus minus 0.1. okay, so for our sake, let's take it as 4 and let's take it as 1. So these two errors containing values, here we will see that when these two get multiplied, how can we, as I told you that the maximum can be with positive 1. okay, so in reality it's a positive negative, and when this get multiplied with positive negative 1, this gives you the multiplication you did. So to find the error, in these we can follow a different step also. That's in this you see that in 100 there is a 4 error, and when you multiply this by 2 you get that in 100 there is error of 2, means there is 4% error and there is 2% error, right? There is 4% error and there is 2% error. So we need to now calculate. If we calculate the percentage, then we may calculate the error also. So first of all I would tell you how would we calculate the percentage. Instead of following the procedure which is given in many textbook, I told in this video I will told you a different method. Okay, so let's take this. These two values are getting multiplied, right? So you may say that if there is of 100 then there is 4, and if there is of 100 and then there is 2 error. Okay, so when these two get multiplied, how much the error will how much percentage of error will be there in the resultant one. So the initial one was when there was 100, means let's say there is, it's denoting some temperature. So when there was 100 degrees Celsius, then by different you may say it as same thermometer also you get two different readings. Okay, so multiplication of these two get like plus minus, means at 100 degrees Celsius there is 4 degree Celsius error, and 100 degrees Celsius there is 2 degrees Celsius error. So if there is no error, okay, so if there is no error, then what's the percentage? The percentage would be 100, like that. So when this is the, its square would be the final one, means you may say it as if someone has some length and its error is getting up to this one. Okay, and I am just squaring this. Okay, so squaring this means I am just adding this one to the unit of times, adding that time. Okay, so how would we find this percentage error? So in square one we would find the square of this initial, the total having squared minus this one would give us the error, divided by the total, this one which was initial, so that we can find how much part of it is containing error, multiplied by 100 would give us percentage. Again I am telling you that if there is a length, you may say, and this one is the error. Okay, so this is absolute, or you may say it as this one is the true value. So how would we find that how much there is error? So this error which would be given to us, and this error which would be given to us, we would just square at the time of multiplying here. So we would just square, because here is also 100, here is also 100 at the time of percentage we are doing. So this would be get square subtracted, this would be get subtracted from the total one. So what this total one would be? This total one would be 100, and for our convenience we are taking here positive only. Okay, so 100 plus 4 into 100 plus 2 subtracted by 100 square divided by 100 square, it's the difference that, and divided by the total, okay, that was initially, and multiplied by 100 would give the percentage. Now here you would see that it would be 100 square plus 200 plus 400 plus 8 divided by 100 square. This get subtracted 100 square into 100. This get cancel out with this one, and the square of it cancel out with the 100 multiplied here. What we get here is 608 divided by 100, which is 6.08%. This is the correct percentage. So in textbook it is given that whatever the percentage here and whatever the percentage here, you need to just add them, and here we got 6.08. That's having more accuracy, right? That's having more accuracy, but we need to just get relation here. Means in textbook which is given that the addition of that approximation is nearly to this. So what's happening here is that we know that every time when we multiply this one and this one, the maximum value would be of hundreds, right? And this 4 into 2 will be get always neglected. The value always we got is this one, which is of percentage. This, by seeing this 4 you get that this is 4%, by seeing this 2 you get that this is 2%. And when this 4 get multiplied by this, because this 100 square get cancelled out with this at the end, and the result and the ending result is 200 plus 400 divided by this. So every time this 4 multiplied by this and this 2 multiplied by this 100, and we nearly get this plus this. Okay, so that's the reason behind that we get its total nearly approximate to this accurate value. So let's consider a question that's if the momentum of any body of an object is increased by 10%. Okay, if the momentum is increased by 10%, then what's the increment in kinetic energy? Okay, so here I need to tell you one more concept, that's whatever the means, if there is any value and it's 10% get increased, this 10% is error. You may consider this 10% as error, because you may say that there is this value and it get increased by this, so this increased value which is of 10% is the total, this value divided by this total, which is multiplied by 100 and get that error percentage. Okay, so this 10% is the error. You may say it as the momentum into v. This momentum is mass into v. Sorry, this is not a momentum, this is mass. So this mass into v, this is constant, so this doesn't increase anymore. The increment is done only in velocity. So this velocity has error of 10%. Okay, you may say it as velocity has error of 10%. Now while finding kinetic energy, we do this is also constant, this is also constant, so k will directly proportional to v square. So v square, what we do, we by given textbook formula, because of the given textbook formula, we just multiply this 2 with this tan and we get that 20% increment. But if you do by the way I told you, this answer is not accurate, this answer is not correct even. So if you do by my procedure which I told you, you would get the correct value. So how would you get that correct value? Is that there is 10% increment. You may say that if there is 100, then the error would be of this 10%, right? So it would be 100 plus 10 square minus 100 square divided by 100 square into 100. So this would be nearly 100 square plus 100 a square plus b square plus 2 into 100 into 10. So 2 into 100 would be 200 into 10 would be 2000. Subtracted by 100 square divided by 100 square into 100. This get cancelled out with this one, and what we got is 2100 divided by 100. This square get cancelled out with this, and the resultant is 21%. So in option these both options were given, but because of given formula in our textbook we follow the procedure and we got this answer. So this one is incorrect, and the procedure which I told you, by that procedure this would be the accurate one. Accurate. Okay, so same thing can be happen in the resistance question also, that if the length is increased by this much percent, so that percentage can be taken as the error, and you may solve further the question. Now if you take an example of you may say that if the radius of a sphere is having 2% error, so what's the error in volume, in its volume? So we know that the volume of sphere is this, and this is constant, so we don't consider this one, we consider only r cube. Now I told you that you may say that the radius was 100, and the because of the presence of 2% error, that may be 100 plus minus 2. Okay, for our convenience let's take 100 plus 2. Now the r cube, that's if that was 100, then the true values cube would be 100 cube. Okay, and because of having plus 2, the its cube would be 100 plus 2 cube, subtract this one, and the total is this one, and multiplied by 100. So what's from our textbook it's simple that you need to just multiply this 3 to the percentage given, that's 2, and you would get 6%. So what's happening behind that is this, that this by not solving anything more, you just need to imagine the things, that this 100, when this get cubed, this get 100 cube, 100 cube get cancelled out with this one, and this 2, there would be 2 cube plus 100 square into 3 means this 300 square into 3 into 2. So this 100 square is large enough to be considered. Okay, now in the second one you get this 2 square into 100 into 3. Now 2 square into 100, this is getting to be of only 3 places. Okay, that's first is 1 play, 10th place, and the 100th place. So we may get only nearly to, as from this one side this would be 4 into 3 is 12, and 1200 nearly, and this 1200 is smaller, much smaller than this 100 square into 2 into 3, that's 60000, this one and this one. So what we do is, we know that after cubing this, we know that this get cancelled out after the calculations, and the remaining is all only the greatest value we need to consider is this 100 square containing. This 100 square containing would have 2 into 3, because of the formula is a square b, or means there is addition of the whole formula is a cube plus b cube plus 3a square b plus 3ab square. So this a cube is get cancelled out this, so we need not to. This b cube is much smaller. This a square b, this a square makes the value very high, because 100 square makes the value in 10,000s. Okay, so this makes the value very high. So because of this, a square is getting to be 100 nearly, means 100 square nearly, and this b, remaining b get multiplied with this one, and the resultant of this would be nearly to this, and when this get divided by this remaining, because of this it get cancelled out with this one, and the remaining here is 2 only, and this get cancelled out. So this 2, now this get cancelled with this one, and we get nearly to 6. Why we get nearly to 6? I told you the reason, that because of this 3a square b. This 3ab square is not that much considered, but as I told you that in larger numbers means when there would be the digits very large enough, then there would be very large error also, and we need to follow a good procedure, a correct accuracy level procedure. Okay, so this was the overview that what the textbook says is really mathematically. I told you that what's the base of that all. So thanks for all that.